Hello everyone and welcome to my channel Octopus Math by Sahiba. Question 8. Complete part A and part B using a straight edge and compasses only. Construct the locus of the points that are equidistant from the line. Okay, so for equidistant points, so the set of points or the locus of points that are equidistant from two points are defined as the points lying on the perpendicular bisector of those 2 points. So first we need to connect x and y. And then we need to make a perpendicular bisector on x and y. So we need to open up our compass for more than half of the distance of x and y. And the reason we do this is when you open up your compass for half of the distance, exactly half of the distance, what you do is when you make an arc, your arcs are not going to intersect. Like for perpendicular bisector, you need to open up your compass of more than half, put it on x, make an arc on the top of the line, make an arc on the top of the line, make an arc on the bottom of the line, and then use the same radius to put the needle on the y, make exactly two arcs the same way, and then try to connect them, right? I like to connect them with a dotted line, so you can do whatever you like. So this is the perpendicular bisector on x and y, and by the property of congruent triangles, if any point on this line will be equidistant from x and y. For example, if you take this point, this will be equidistant from x and y. That means if you take this point as P, for example, the distance between Px and Py will always be same, because this point has to be the midpoint because it's perpendicular bisector by the definition, and also perpendicular. So by the definition of congruent triangles, px and py will be equal, right? So if you take any point on the this perpendicular bisector, it will still be the same. So you don't have to basically prove that uh, by drawing this point P. I think the perpendicular bisector thing should be enough for it. Correct, perpendicular bisector drawn with 2 points of 2 pairs of arcs, right? Part B1, construct the locus of points that are equidistant from the line AB and AC. So when we're talking about the line AB and AC, we are talking about their angular distance between two them. So we have to divide them equally, which means we need angular bisector, right? So we need to bisect the angle A, which is between AB and AC. So for angular bisector, we need to put our compass needle on A with any radius, make an arc here and here, and you can change the radius, you can keep this radius as it is. Put the needle here on the new arc, new intersection point, make an arc here, put the needle here, make an arc here, and then connect. Because this is not that accurate, I'm just telling you how you would do it, right? Please make sure you're accurate with this. So this is angular bisector. Okay. Part 2, shade the region inside the triangle which is closer to AB than to C. All right. Closer to AB is this section, right? And closer to AC is this section. So we are interested in shading the section which is closer to AB. So because AB is this line, therefore, this side of the angle bisector is all the points lying in this side of the angle bisector will be closer to the line AB. So we have marked it. Correct region shaded, dependent on the line. Okay. So yeah, we're good. And then part C, complete this part using a ruler and compasses only. Construct the locus of points that are 4 centimeter away from the line MN. Okay, so 4 centimeter, now there could be infinite many points, infinite many points which are away from the line, 4 centimeter away from the line. I mean, this point could also be 4 centimeter away from the line by telling you that this point is exactly 4 centimeter, which means it's perpendicular distance I'm talking about, right? So this point could be another line which is 4 centimeter away from this. There's many. So how would you do this? You will have to create a line perpendicular to MN, right? You can do this by using a set square, right? um, make a line which is exactly 4 centimeters away. All right, and that's how you do it. You can use set square if you want, you can use a pair of compasses or whatever. So what you need to do is that you basically have to draw a line equal to the length of the line mn, such that the distance between these two lines is 4 centimeter. Okay, how will you how will you do it practically? I don't have these things with me here, but at least I can tell you the how this is done. So first, what you need to do is pick up 2 points on the line mn. So let's take m and n only. So let me draw uh, a 90-degree here. So this is roughly 90 degrees. This is 90 degrees, right? And again, I want my another 90 degrees because I want the perpendicular. I want to see the perpendicular distance, right? So this is 90 degrees. And then what we need to do is we need to connect these two with basically this is 4 centimeters away, which means we need to make a rectangle. Now this is 4 centimeters. This is 4 centimeters. It has to be 4 centimeters away, right? So you open up your compass of 4 centimeters and make an arc. So let's say that this is 4 centimeters. Okay, put your needle on M and make another arc of 4 centimeters and then connect these two. So basically we've made a rectangle, right? Because other than rectangle, if you make a trapezium, so this point will not be away from perpendicularly from 4 centimeters away from the line mn, because the this line segment mn stops at n, right? So any point other than this would not be acceptable. Correct loci drawn. All right. B1 for 4 centimeters are drawn. Centers M and N, fine. Two straight lines drawn parallel to M and N, and 4 centimeter from M and N on each side, fine. Okay, fine. Fine, that's good. Thank you for watching. Share my videos with your friends and family to spread the knowledge. Also, keep watching for more videos.